All right, let's talk density curves. All right, basically, a density curve is like this idealized, perfect representation of what the data looks like. Okay, and if you look at these different pictures, like this is what the sample looked like, and maybe it's like this wavy blue line going through here, or maybe it's actually just meant to be uniform, and it's just a uniform distribution, but because of randomness, some of them were a little bit higher than they should have been, and some of them were a little bit lower than they should have been, okay? And you look at this distribution, and I would say it looks maybe a little bit skewed right or something, right? And so is it like the blue picture that has this little extra bump out here, or is it just meant to be a symmetrically like normal-ish curve? This one definitely looks skewed right, right? Is it like a blue with a little flat bump there, and right, we don't know exactly what it looks like, but we try and just make a general curve. And so like these orange curves, this one I would probably just make skewed right. I probably wouldn't even put that little bump in there, right? I just make it skewed. I wouldn't put that little double dip. But it's an idealized picture of what it looks like. Okay, now what are the attributes of it? Well, it's always done with quantitative data. Okay, you put it above the x-axis. All right, so it's always going from 0 up to some height, and the total area under it is always 1. That is the most important thing. Okay, it never dips down into the negatives. Total area is always 1. And why might that be important, you might ask? Well, because since the area under the curve is 1, we can use the area as a proxy for probability. Like we can calculate the area under the curve, especially using calculus and integration. If you have an equation for the curve, you could integrate, but we also have tables and calculators that can do it for us. And so if I want to know like what's the probability that I'm going to land between A and B, what's the probability that I'll land between A and B? Well, if I could find the area of the curve in between A and B, well, the whole curve adds up to 1, so the whole curve adds up to 100%, and the area here would be the probability that I land between A and B. And so the power of using density curves is mathematically, we can use calculus to describe the equation of this shape. And once you have an equation of a shape, you can integrate and calculate the area between any 2 points, which is awesome. All right. So we're going to use tables and our calculators, so you don't need to worry about the calculus in this course. All right. So the mean and the median are the two things that we typically talk about. The median we know is the middle number in our data, so it splits the area 50-50. Okay, so if I colored in this purple area, and all you Lakers fans, this yellow area, you can see that it's 50-50 right here. Okay, the mean is the balance point of your density curve, so it's pulled towards the tail, right? So it doesn't balance over here where it's really tall. It doesn't balance way over here where it's too skinny because then there's too much weight on that side, but it balances perfectly at the mean. It's the balance point of our curve. And then last but not least, this quick example, okay? One or two of these lines are the mean and the median, okay? So if it's symmetric, like curve A and curve C, the mean and the median will both be right in the middle. So even though the peaks are here at A and C, okay, the mean is here because everything would average out, and the median's here because it splits the area 50-50. Same thing in this one, part C. A is the mean because everything on the right and left would average out and cancel, and it would balance perfectly at it, and it's the median because it's 50-50. Okay, here you see that the mean gets pulled to the right by the tail. So the 50-50 point is A in this picture, but the balance point is B. So A would be the median and B would be the mean. And then here in this last one, part D, it's skewed left, and so the mean's going to get pulled towards this tail, and if we tried to balance it, it would balance at point A, and if we tried to split the area 50-50, it would be point B is the median. So A is the mean, B is the median. I hope this gets you ready for some density curves. Good luck and farewell.